Alright everybody, welcome back. Here we are, video 2 for section 9.9 of AP Calculus BC, finding the area of the region bounded by two polar curves. And we're going to go through a couple of AP problems that relate to this topic in this video. So we're going to start with example 4 here, which comes from the 2018 AP Calculus BC. It's free response question number 5 from that year. It's a non-calculator question, and let's see what it has to offer. The graphs of the polar curves r equals 4 and r equals 3 plus 2 cosine of theta are shown in the figure below. The curves intersect at theta equals pi over 3, which is this intersection point right here, and theta equals 5 pi over 3, which is this intersection point right here. Let R be the shaded region that is inside the graph of r equals 4, so it's inside this circle, and also outside of the graph of r equals 3 plus 2 cosine of theta. So now we want to write an expression involving an integral for the area. Now imagine the radii coming from the pole here to this region, and there's nothing tricky about this region at all. It's very straightforward. We've got our outer curve 4 and our inner curve 3 plus 2 cosine of theta, and those are the curves over the entire region. So this is going to be 1/2 times the integral from the first intersection point to the second intersection point of the outer curve, which is 4. If you look at all these lines going away from the pole, 4 is further away from the origin in all of them, so 4 squared, minus the quantity 3 plus 2 cosine of theta, quantity squared, d theta. This was a non-calculator section. They asked us to write an expression for this, but did not ask us to integrate, so we are done with that particular problem. All right, slide on down the page. Example 5 comes from the 2014 AP Calculus BC exam. It's free response question number 2 from free response question number 2, which was a calculator question. So we see here we've got the graphs of the polar curves r equals 3 and r equals 3 minus 2 sine of 2 theta, shown in the figure below. Theta goes from 0 to pi. This is a calculator question, so I could graph these two curves and use that to help me along the way, although I don't know that I'm going to need to. Let R be the shaded region that is inside the graph of r equals 3 and also inside the graph of r equals 3 minus 2 sine of theta. Find the area of R. So we are going to actually have to calculate the area. So you think about it, think about the segments emanating from the origin to these curves, and we have a definite transition that goes on. Starting over here, it's the area inside of 3 minus 2 sine of theta. So from this angle, which is 0, to this angle up here, which is pi over 4. Is that pi over 4? Is that pi over 2? What is that? Let's use our calculator to make sure that we get the right limit of integration. So we go to y equals, clear it out, got r equals 3, and r equals 3 minus 2 sine of 2 theta. And I'm graphing this from, let's go from 0 to 2 pi. And yeah, that should be good. Okay, so if I trace this starting at 0, where do these intersect? Okay, that is at pi over 2. I just wanted to make sure that is at pi over 2. So the first part of the region, we've got 1/2 times the integral from 0 to pi over 2 of the curve 3 minus 2 sine of 2 theta. quantity squared d theta, and we're going to add to that the area of this piece over here, which I'm allowed to calculate this in a bunch of different ways on my exam. I could just say, hey, this is a quarter of a circle with radius 3 and do it that way. Or I can find the area inside the curve from pi over 2 to pi. Doesn't really matter which one of those you do. Oops. As long as you do one of them and add it to the area of the other region. So we'll go ahead and break out our calculator now. And I've got 1/2 times the integral of the quantity 3 minus 2 sine of 2 theta, quantity squared, with respect to theta, from 0 to pi over 2, plus 1/2 times the integral of 9 with respect to theta, from pi over 2 to pi. And we calculate that. And we get 9.708. 9.707 is also acceptable, the truncated value. All right. And why not? Let's do part B of this question as well. For the curve r equals 3 minus 2 sine of 2 theta, find the value of dx d theta at theta equals pi over 6. Okay, so dx d theta, let's see. So I can write x. X is equal to r cosine of theta. Therefore, x is equal to the quantity 3 minus 2 sine of 2 theta times cosine of theta. Now, if I want to evaluate this at theta equals pi over 6, I can go ahead and do that using the numerical derivative on my calculator. I'm going to take the derivative of the quantity 3 minus 2 sine of 2 theta times cosine of theta with respect to theta at theta equals pi over 6. Punch this up on my calculator, and I get negative 2.366 for the value of dx d theta at pi over 6. And we're done. That takes us to the end of the lessons for this unit. There's some practice problems for you to do and some review to do before we get to our test. Well, our quiz and our test. But that takes us to the end of our instruction for this unit. All right, see you next time when we start Unit 10, the final unit of AP Calculus. All right, see you then. Have a great rest of your day. Bye-bye, everybody.